Assalamualaikum, you are with me again, Miss Huda. Let's continue with the stability calculations for the chapter of gravity retaining wall design. A retaining wall is said to be stable if a limit states set out are not exceeded, meaning that in our last recorded video, there is 5 limit states or 5 failure criteria. So the limit states must not be exceeded, if not the retaining wall will not be safe lah ataupun not stable. Therefore, a number of calculation must be made as follows. The first one is to calculate the weight and the lateral thrust. On these matters, what we must do is we must find the weight of the wall and the lateral thrust acting at the back of the wall due to the retained material. The retained material akan produce horizontal forces, while the weight of the wall will produce vertical forces. Next, we need to determine the position on the ground reaction. From both forces here akan ada ground reaction because of ini akan being transferred to the ground. All the forces will be transferred to the ground. Therefore, because of the transfer pada ground, so ground ni akan ada reaction yang akan counteract the forces yang acting at the bottom of the wall. Next, we're going to determine the ground bearing pressure because we need to know what is exactly from the forces here. Okay, so dia akan transfer the load ke bawah, so akan ada pressure from the forces. So kita nak tahulah because of the ground ni ada safe pressure dia, safe ground bearing capacity. Berapa maksimum yang the ground boleh support. So, kita nak make sure that the ground boleh support lah all the loads that coming from the retaining wall and the retained materials. Determine the factor of safety against overturning. So, kita nak make sure that the wall will be safe and will not overturn. And determine the factor of safety against sliding. Kita must make sure that the wall will not slide, meaning the friction is enough untuk resist the wall from sliding. First step tadi, we need to calculate the weight of the wall and also the lateral thrust. So after that, the second step is we need to determine the position of the ground reaction. So kita nak tahu kat mana position dia dekat ground ni from all the forces yang acting dekat retaining wall ni, dia transferred pada ground. X, denoted it as X. And V adalah the reaction, or we can also call it as the RV. Daripada forces ini dan ini, di manakah exactly positionnya? We can use the formula, the position on the ground reaction, denoted as X, B minus total stabilizing moment minus total overturning moment and divide with total vertical forces. B is the base, which is if you have the cross section of retaining wall look like this is B. So the value of X yang kita nak adalah position dia. For example, the one that color pink here, this is X. We're going to take the distance from B, which is the hill. Belakang ni adalah retained material. So total overturning moment maksudnya adalah daripada forces yang try to overturn the retaining wall, which is forces daripada the retained material ataupun lateral thrust tu. For example, you have force from liquid ataupun soil. So itu yang try to overturn the retaining wall. So we're going to take the moment from that forces. While for total stabilizing moment, this is the moment that come from or produce from the vertical forces ataupun the weight of the wall yang cuba untuk stabilizekan the retaining wall. So itu adalah moment yang datang daripada weight of the wall. And last kali we have a total vertical forces, which is the weight of the wall. Bahagikan saja and you will get the value of X from B. Berapa di sini. Next, we going to calculate the ground bearing pressure to make sure that the pressure of the ground do not exceed the limit of bearing capacity of the soil. We're going to use this formula, or we can also use this formula. Ada dua formula. These two, ini dan ini adalah sama ya. So kalau you kira tak kisah pakai ini atau ini, you will get the same answer. But your options right now is whether you going to use this two formula here, or you going to use the formula this one. Depends on the middle third rule. Okay, I'm going to write another formula yang tadi, which is QA/B equal to V over B plus minus 6VE over B square. Formula yang di sini adalah untuk kalau the value of X is inside middle third. And for the other formula up here, this one kalau X, which is the position of the ground reaction, is outside middle third. We need to understand what is the middle third. If you have a retaining wall that look like this, you're going to divide it into 3 sections, starting from B to A. If you have a retaining wall that is 3 meter, so you bahagi 3. Di sini kosong, di sini 1, di sini 2, di sini 3. So total dia adalah 3 meter. So middle third is between 1 to 2 meter here. Ya, yang dekat tengah-tengah ni. That's why nama dia middle third. 1 ke 2 meter. So kalau you dapat value of X, for example, you get the value of X equal to 1.71 meter. It is between 1 to 2 meter, which is inside, masih lagi dalam middle third area there. Therefore, when you going to calculate for the ground bearing pressure, you going to use formula ini. Sebab dia berada dalam middle third. Kalau you dapat value of X is equal to 2.01 meter. Dia dah lebih dari 2 meter. So, you akan pakai formula ini untuk calculate the ground bearing pressure. Itu yang we have to understand about this rule Sebab kita nak kira the ground bearing pressure, ada 2 formula yang berbeza, depends on the position of ground reaction ataupun X tu. Okay, so bila you tengok formula ni, you mesti confuse sikit lah sebab dia ada slash kat situ. Maksudnya QA adalah sama dengan V over B plus 6VE over B square. QB nya adalah V over B minus 6VE over B square. So ini maksudnya ada slash A and B here and ada plus minus. Inilah dia. V here represent the vertical forces, or kita panggil juga RV. And the B adalah the base, which is kalau 3 meter, base-nya di sini, that is the value of B. Then 6 here, darab dengan V. V pun sama, RV itulah, which is the vertical forces. And E here means eccentricity. Eccentricity ni maksudnya adalah you ada value of X. For example, I put here 1.71 meter. So eccentricity would be the distance between the value of X sehingga tengah-tengah base ni. Kalau B adalah 3 meter, so tak kisahlah the cross section rupa macam mana pun, we don't need to find the centroid ya. It should be from the center of the retaining wall ni. Maksudnya B bahagi 2 lah. Setengah saja dia nak. 3 meter bahagi 2. So you akan dapat 1.5 meter. So distance daripada X sehingga tengah-tengah retaining wall 1.71 meter tolak 1.5. So itu adalah eccentricity. So ini adalah E and B masih lagi the base lah, which is 3 meter. Same goes if you use this formula. Eccentricity di sini maksudnya masih sama. Itulah maksud dia. You pakai formula ini, meaning the case yang X outside middle third, you boleh option pakai ini atau ini, tak kisah. Tapi nak senang, kira pakai inilah. You tak perlu kira the value of eccentricity. Ambil je terus value X and masukkan dalam formula ini. QA sama dengan 2V. V sini maksudnya RV lah. 3 in the bracket the B, which is the base 3 meter, and the value of X, which is the position of the ground direction. Okay, if you look at here, ada QA saja, while the other formula ada QA and B. So QB-nya ada. QB-nya value dia memang sentiasa kosong. Untuk formula, kalau X outside middle third. Kalau kita lukis the pressure distribution of the retaining wall, kalau case-nya seperti ini ya, which is outside middle third, ini adalah B, ini adalah A. So you akan dapat pressure distribution-nya seperti ini ya. QA akan ada value, however dekat B akan jadi kosong. Dan kalau case-nya seperti X inside middle third, so you akan pakai formula ini, the pressure distribution-nya akan jadi macam inilah, which is QB is lesser than QA. QA akan lagi besar dari QB. Next, we have overturning, which is we need to determine what is the factor against overturning, or we call it FOV. The formula is stabilizing moment divided with overturning moment. Stabilizing moment denoted as MS and overturning moment as MO. Last kali, for stability calculation, we need to find the factor of safety against sliding ataupun FS. The formula is actually ini ya, which is we have the RS, the resistance from sliding, bahagi dengan the lateral forces ataupun P di sini. So daripada retain material lah, value P ni kita akan cari ya. Horizontal forces itu. RS ni maksudnya adalah mu V. You boleh refer di sini. So that's why in this formula dia replacekan mu V over P. And value of mu ni pula, kalau mu tak diberi, kita kena cari mu. Mu is tangent delta. Delta is angle of wall friction. Kita kena cari value of mu, baru darab dengan the vertical forces ataupun kat sini RV lah. Bahagi dengan RH ataupun P. Total pressure at the back of the wall. That's all for the recorded video for stability calculations. I'll see you again in our next recorded video. Thank you so much and bye.